Good day everyone, I'm Kenneth, Olaivar, and today I will be discussing about Unified Modeling Language or UML class diagrams. I hope that everyone from this report you will learn and gain a better understanding of how UML helps in designing and planning software systems. Okay, so today I'll be tackling about the uses of software design specifications. What is Unified Modeling Language? What is a UML class diagram? And how and when to use class diagrams. So what is a software design specifications? So software design specifications are a way to specify how a system will work without writing a complete implementation. The requirements specify the what is to be built, the design specifications is the how. So think of it like wanting to buy a toy car. So for example, this one, the requirements of this is like, I want a toy car that can move and has 4 wheels. That tells us the goal, that the design specifications, and then explains how we build it. Like use 4 round wheels, attach them to a small body, add motors so it can move, and place the battery inside. So in software, if the requirement says users should be able to log in, then the design specifications describes how it will happen, such as the user entering a username and password. So the system checking the database and then allowing or denying access. So in software design specifications, we use design specifications to get feedback from coworkers and users, get approval, and avoid problems in implementation. So what is Unified Modeling Language? UML, in short, is a standard for modeling object-oriented software. This has many different diagrams and notations. In practice, companies use a subset of UML and modify the form. It can also simplify diagrams if they do not add clarity and are not needed by your team. So in short, UML helps developers and designers understand and plan software before building it. So we have the UML uses. UML can be used as a sketch to communicate some parts of the system. It can also be a blueprint to follow when implementing the system. And last is, as a programming language, it can automatically generate code. So we have here 2 common UML diagrams. The first is the class diagrams, wherein it describes the static structure of the system. And then we have the sequence diagrams, wherein it describes the dynamic behavior between the actors in the systems. So we have here a sample of the class diagrams. We have here the classes, customers, and the superclasses order. Then we have here the generalizations, and then the attributes of the superclasses. We have the date, number, confirm, close, and then its methods. And then we have here the subclasses, special order and normal order. But today I will only be tackling about the class diagrams. I will not further discuss sequence diagrams because another person is allotted to the topic. So the difference between class diagrams and the sequence diagrams is that they show different aspects of a system. A class diagrams shows the structure of the system, including its classes, their attributes, their methods, and relationships. In contrast, a sequence diagram shows the flow of interactions over time, illustrating how objects communicate with each other in a specific process or scenario. So in short, sequence diagrams are quite tricky because it has a lot of processes, unlike in the class diagrams. So class diagram. In the class diagram, the goal is to convey information about the static structure or the fixed structure of your system. It also focuses on classes, their attributes, and methods and relationships between classes. It is also used by application domain experts and developers to model the domain and design the software. Customers and end users are not usually interested in class diagrams. It is best if you build class diagrams iteratively. So, class diagrams, this was tackled during our OOP subject last year in my first year. And to give a recap, so we have here a class name animal and its attributes. We have here the ages, the age, the gender, and its methods. Like, is the animal a mammal, or is the animal mate, something like that. And then we have these subclasses, which are the duck, the fish, and the zebra, and it has also its methods and attributes. Okay, so what is a class notation? So class notation is it consists of class name attributes called operations in UML. It has details in class diagrams vary based on theme, project context, and tools. Some things it may include parameters, attributes type, getter and or setter methods, and method return types, and its visibility. So in class notation, it is the standard way of drawing and representing a class in a class diagram. So we have here association. So what is association? It is used when at least one class makes reference to another. The relationship is not transient. It also has options to include like the name of association, multiplicity, navigability, and we can show here its example. So a person has its address, like for example its attributes like the street, the city, the postal code, and its country. So in association arrowhead, in association, it represents a connection between the classes and its subclasses. So we also have association arrowhead. So this is optional and usually means the class at the tail has an attribute of the type of the class pointed to by the arrow. For example, a person has an attribute for their address. So it is the same with the association before. And also in association arrowhead, it shows the direction of the relationship between two classes. It indicates which class knows about or uses the other class. For example, if a teacher arrows a student, arrow exists, it means the teacher class interacts with or refers to the student class. We have here multiplicity. Multiplicity is used in associations to indicate the number of instances. Examples 0, 1, no instances, or 1 instance, 0 or more. 1 exactly 1, 2, 2 or more, 3, 7, between 3 and 7 inclusive. So in our example here, the same class and its subclasses. So they're interconnected, and person lives at one address, and each address has 0 or more people. So basically, in multiplicity in a UML class diagram, it shows how many objects of one class can be related to objects or another class. It is written as numbers or ranges near the association line between classes. For example, 1 means one too many, such as one teacher teaching many students. Generalization. This represents an inheritance relationship. It is represented by an unfilled triangle. And the student, for example, is this: a student is a person, inherits from a person. And these also do not display parents' attributes and methods in subclasses. So, okay, so this example shows what we can see here is that in a UML class diagram, the student class is a specialized type of the person's class, meaning the student inherits the attributes and methods of a person. The arrow with the hollow triangle pointing to the person indicates that the person is the parent or the superclass, and the student is the child, the subclass. So the student also has first name, last name, birth date, and the get full name function, in addition to its own student number. Okay, moving on, we have here the association types. So, first is the composition. When an object is composed of other objects, the parts will be removed with the whole, shown as a field in diamond. Okay, so for example, the shopping cart is a part of a customer and will be deleted when that customer is deleted. So, so they're related. So if ever one doesn't exist, the other will not exist also. So we also have the same slide. Okay, so moving on, we also have aggregation. When an object is a part of another object, shown as an empty diamond, not a verse one. Okay, moving on, we have here the class attributes. So, what is a class attribute? So, class attribute can use additional notation to define a class attribute. So, this format follows: visibility, name, then its type, then its multiplicity, equals to default, and property string. For example, name and then a string, an array, and its name untitled. Yeah. Okay, so just an example to give an overview. So in short, so we have here example written in Java. So we have here its super class student, and then we have here its attributes, like for example its student ID, its name, and its phone. And then in the student ID, we have here its unique ID number, and each row they have its unique properties. There we can conclude that in every attribute we have here its unique definitions or attributes also, or in a overall, like in a class they have its unique attributes. Okay, so in naming conventions, we also have naming conventions, and we have here its examples. Like first is the camel case, when you write words together capitalizing the first letter of each word. Like here, we have here in the camel case, capitalize the words, the first letter in the word. It has its two styles, which is the lower camel case, wherein you will not capitalize the first letter. Like for example, lower camel case. The L in the lower is not capitalized. And we have here the upper camel case, wherein you capitalize the first letter. For example, the first letter U in the upper, and the C in the camel, and the C in the case. So we use upper camel case for classes, like lower camel case for attributes. And also we make classes singular, so to avoid confusions, and we make attributes singular unless they are a collection. In naming conventions, we also use nouns for class and attribute names, for verbs for method names. Lastly, we use application domain terms, not in programming terms, for easy use. So how do you determine classes? So for example, we in this diagram, we have your class dog, and then we have your, it's dog number 1, dog number 2, number 3, and its attributes, like for example, its breed, its age, its colors, and its like its behaviors, like does it bark, sleep, eat. It's a procedural programming, we can say. And how we determine classes is first is to identify from project requirements, and second is Abbott's textual analysis, also called as noun or noun to verb analysis. Nouns are good candidates for classes and attributes, verbs are good candidates for methods. And lastly, we also apply design knowledge and follow design patterns. So we also have non-domain classes. So what is a non-domain class? So non-domain classes are classes that do not represent real-world concepts in a problem domain, but instead help the system run, manage data, or control processes. For example, we have here database manager. So this handles database connections and queries. And we have here login controller, manages the login processes of users. File handler reads from and writes data to files, loggers, record systems, events, etc. So in short, these classes support the system's operations but do not represent real-world entities like student, teacher, or product. It also will need to determine necessary classes not associated with the domain. Some examples are controller objects, authentication objects, web sharing objects. We also have here object modeling. So object modeling is the process of representing real-world objects, their attributes, and their relationship in a system to help design software. So, for example, what we can see here, it's class name is vehicle, and we have here its methods, its attributes, like for example, the land, the water, and the air. So it is a generalization, but in its specific, we have its specifications. Like for example, in land, we can use car or bus, and in water we can use ship or boat, and also in the air we can use airplane or helicopter. So in designing an object model, or in object modeling, we have to first identify classes. Second is to determine its attributes. Third is to determine the methods. Fourth is to determine the associations between classes. And also, what happens if we make the wrong abstractions? First, we have to iterate and correct your model. So before writing a code, this will in essence build a stub version of your system. So in summary, this can be useful for understanding entities and their relationships in the system. It also assists in designing and refactoring. Third is to see dependencies between objects. And it can also have its not useful for understanding. First is application control flow. steps to solving use cases, and algorithmic operations. That's all for the report, and I hope you learned something, and thank you for your thank you for listening. Thank you.